Hi, this is a video on simple and compound interest. We're going to look at the difference between them, and we're going to calculate each one with an example in a table form, and then look at the formulas at the end. Okay, so first of all, the definition: simple interest is interest that is only earned on the original amount, or if it's a loan, it's only paid on the original amount. Versus compound interest, where interest is earned on the original amount and any interest added to the account. So compound interest is more common in bank accounts, where you have money in there, you get interest periodically, and then the next time you get interest on the full balance. So your interest is earning interest over time. Simple interest is more common in informal situations. Let's say you want to loan some money to your cousin, and you say, "Oh, just pay me back 5% interest at the end." That would be an informal agreement and a simple interest. Okay, so let's calculate each one of these. So here's an example. You invest $500 and you earn 6% interest every year for 5 years. Okay, so we're going to start with 500 and our balance. To find the interest we earned on that, we need to take 6%. So we're going to change that to a decimal, 0.06 times $500. Let's see what this is. $30. Okay, so after 1 year you have $30 of interest. If we add that, our new balance is now $530. Okay, year 2, you get interest again, but it's simple interest, so you only get interest on the $500. Still $30, so now that's going to be 560. Okay, this is going to stay the same. I don't think we need to write it out every single time, because simple interest, you get the exact same amount of interest every single time. So we're going to keep adding on $30 here. So 590, 620, and we have $650 at the end of 5 years. Okay, so now for compound interest, we have the same example, so we can compare our answers at the end here. So you invest $500 at a rate of 6% interest, compounded yearly. So with compounding, they have to tell us the interval or the periods of compounding. Again, for 5 years. So we start with $500. We take 6% of 500. We already know that's equal to $30. So we have $530. So the first year looks the same. But the second year, now we get interest on the whole balance. So we get interest on the $530. So let's see, I'll put this over here now. Let's see what this comes out to be. 0.06 times 530, 3180. So we got interest on our interest. Isn't that interesting? So let's add this on, plus 530, 561.80. Okay, let's keep going. Now we get 6% on our 561.80. So on my calculator, I've got it there, so I can just go times 0.06. 33, I'm going to round it because it's 708, so I'm going to do 71 cents, plus 561.80 gives me 595.51. Now you notice I'm rounding. We'll get to the little easier way to calculate it with a formula in a minute. Doesn't hurt to practice doing our percentages though. So 0.06 times 595.51. Actually, if I leave the full decimal in my calculator, then I won't have the round off error. So I'm going to take that times 0.06 and that's 3573 plus 595.51. That is 631.24. Okay, and one more. 0.06 times our 631.24 times 0.06. 3787 plus 631.24, 669.11. Okay, so now let's compare our two accounts. Simple interest versus compound interest after 5 years, and this is compounding only once per year. $669. So we've already got more money by compounding than we did in the simple interest. We'll talk about different rates of compounding in the next video. Okay, so this was kind of a long way of calculating it, just to see how it works. We have some formulas if we wanted to go right to the 5 years. What if you're saving for retirement and you want to calculate something 40 years out? You don't want to do this 40 times. I'm sure you don't. So we have a formula to jump right to the end. Okay, so let me write them down and then I'll show you where they come from. So for the simple interest, A is the ending amount. A is equal to P plus PRT. And this is what we were doing each time. We were taking the principal, which was 500, times the rate, which was 0.06, and then we were doing 1 year at a time, so it was times 1. And then we added it on to our balance. So that's what we did. Let's just do a calculation for year 5. We would have, let's check it. A equals 500 plus 500 times 0.06 and times 5. If we want to just jump ahead, skip the whole table, just get this ending number. Let's make sure it works. 500 plus 500 times 0.06 times 5, or you can use parentheses, doesn't matter, $650. Okay, so in practice, more often you'll use the formula. Now the formula for compound interest is a little different because here you're getting the same $30 every single time, so it's an add, it's a linear pattern. With compound interest, it's actually a multiplication pattern. We're taking P times 1 plus R to the T. So you can see we have the same inputs, P, R, and T, but they're used in different ways. So what does this mean? 1 plus R to the T. I think it will help if I write in the numbers for this example and we can talk about it. So for this example, we started with 500, and then 1 plus R would be 1 plus 0.06 to the 5th power. Now another way to write this 1 plus 0.06, oops, 500, is 1.06 to the 5th power. Now this is where it gets really interesting because this means you're getting 106% of your money. So that's what's happening every time. We're taking this and we're multiplying it. We're getting the same 100% that we had, but we're getting an additional 6% on that number. So instead of, this is the long way of doing it, and you might have been saying, I know there's a faster way. Let's do an experiment over here. So if I take the 530, multiply by 1.06, that is a shortcut way to get this answer, 561.80. Now if I do that again, times 1.06, 595.51, times 1.06, 631.24, times 1.06, 669.11. So we could have just done it that way, but it doesn't make as much sense until you've gone through the process yourself. Okay, so that's what the 1 plus r is doing. We're taking 100% of our money, we're adding on the whatever percentage for the interest rate. And then we did that 5 times, so that's raised to the 5th power. We multiplied our number, our original 500, by 1.06 5 times. So if I start over at the beginning with this formula, if I want to jump right to 5 years, I have 500 times 1.06 caret, whatever your exponent key is on your calculator, or in Excel. We'll talk about Excel and Google Sheets in later videos. To the 5th power, 669 and 11 cents. Pretty cool, huh? Now you could type in your formula here if you prefer. You could go 500, but then you would need parentheses, 1 plus 0.06 to the 5th power. Okay? So those are the formulas if you want to do them by hand. There's one more formula that I want to show you for the compound interest, and then we're going to use Excel to do the more complicated compounding formulas, but it's good to be able to use these two for other periods of compounding. So this worked because we were just compounding once per year, but that's not very common. You want your money to be compounding a lot more frequently than that. So there's a more general version of this formula. A equals P times 1 plus R over N. So N is the number of times that your money is compounding. So let's say it's monthly. You wouldn't get the whole rate every single month, but you would get 1/12 of the rate every month, and it would add up to the whole rate over the year. And then instead of just going once, say, per year, you would multiply N by the number of years. For example, 12 times the number of years. So it would actually be compounded 12 times every year, but you would get 1/12 of the rate. Okay, you might be wondering about that. We are going to use Google Sheets or Excel to do these more complicated problems, and we'll be looking at that in the next video. So I'll see you there.